Hello, this is Guillermo Campitelli, and in this video I'm going to present a case study in which both the dependent variable and the independent variables are nominal. So we are interested in the effect of a nominal variable on another nominal variable. I will also present the descriptive statistics and the different parameter estimation approaches. Okay, so the case study is about the cognitive reflection test. That's a test in which there are three questions, and for all these three questions there are intuitive answers that come quickly to your mind, and you have to inhibit them. And then if you are able to do that, finding the correct answer is not too difficult. So basically, the research that we are interested in this video tries to see whether changing the type of problem would affect the type of response in this cognitive reflection test. So in this cognitive reflection test, there are three types of responses that could be given. One is the intuitive answer, which is incorrect. Second, the correct answer, but then there is any other incorrect answer that is not the intuitive, so it would be other. So we've got three types of responses: intuitive, correct, and others. So basically, the possible values of the dependent variable here are nominal. Okay, so in this research, a researcher was interested to know whether different types of problem would change the distribution of responses in these three types of responses. So one was using the original problem. In another condition, the researcher was interested in whether using the mathematical structure, so a mathematical equation of the problem, instead of presenting the narrative, would improve performance. And in another condition, there was this hypothesis that if the problem is presented with in a condition in which the ink is blurred, that would make the participants to read the problem more slowly and reflect more. Therefore, that would improve their performance in this task. Okay, so basically we've got three conditions which are nominal, and three types of responses that also belong to a nominal variable. So this is the design. We've got 210 participants which are distributed to three conditions to which that correspond to the independent variable, which is type of problem. So 70 participants will be in the original condition, 70 in blurred, and 70 in the mathematical formula condition of the problem. And the dependent variable is type of response, and it has three possible values: correct, intuitive, and other. Okay, so in order to show the descriptive statistics, we are going to use JASP, but because JASP doesn't do the bar plot graphs, we are going to use Jamovi as well to see those graphs. Okay, so first let's start with JASP. We go to descriptive statistics, descriptives first, descriptive statistics, and then we put the variable type of response in variables and type of problem in split. So basically we are going to get the responses but as a function of the type of problem. And we are going to use frequency tables. So here JASP gives us the frequency tables that we need. We can do plots and do distribution plots. And it shows us here the plots in each condition. So basically in the blur problem we've got the number of correct answers, the number of intuitive answers, and the number of other answers. So quite close, correct and intuitive, and much less other responses. In the mathematical form, mathematical condition, we've got more correct than intuitive and more intuitive than other, but it's quite different, the distribution, than this one. And here it's in the original problem we've got more correct than intuitive and more intuitive than other, but the difference between intuitive and other is much more than in the mathematical problem. Okay, so this is the descriptives that we get with JASP, and as I said, if you want a bar plot, we use Jamovi. And I get you Jamovi here. So what we need to do is again type of response as variables and type of problem as split by. We can do frequency tables, and we get this table, and we can do plots. And we have the bar plot that we didn't have in JASP. So the bar plot is going to come here, and here it is. Okay, so basically we've got for the correct type of response, intuitive type of response, another, and in color the type of problem. Okay, so here you have to play around which way you want to present the results. I would present the results in the other way around. Here the type of problem, and in color the type of response. So in order to do that, you would have to change the split by, just invert. So type of problem in variables and split by type of response, and there you've got a better graph. So that's the blur condition, the mathematical condition, and the original is the same as what we saw in JASP, but we've got an integrated graph. So if we return to the slides, so here we've got the graph that generated by Jamovi, and this is the table generated by JASP. So as we can see here, here we've got a frequency, and here the percent. So in the blurred, we've got similar amount of correct and intuitive, and much less other. In mathematical, correct is much more than intuitive, and intuitive is a bit better than other, but not too much like in the other cases. And correct in the original, got 50% correct, 42 for intuitive, and 7% for other. Okay, so these are the descriptive statistics. Now we're going to move on to the parameter estimation approaches. And in the parameter estimation approaches, we've got the traditional frequentist, Bayesian, and resampling. And these parameter approaches, parameter estimation approaches, are about estimating the proportions. So we've seen these in previous videos. Okay, so for the traditional frequentist approach, just was not hasn't been very useful for using it for the parameter estimation of the traditional approach. but by using a trick here we can use it. So instead of using the whole data set, now we use the data set in which includes only one problem at a time. So we've got a data set for the original cognitive reflection test, another data set for mathematical, and another data set for the blurred type of problem. And then we are going to use a binomial test and obtain the confidence interval of the proportions. Okay, so here we've got JASP, and instead of using the original CRT, the CRT which includes all the data, we use the data sets that have a one problem at a time, not the whole. So this one has only the original problem. So we need to go to frequencies, binomial test, and it doesn't matter what you put here at test value because we are not testing. This is parameter estimation. What we want to do is to obtain the confidence interval. And obviously we need to put the type of response on that box, otherwise you don't get any data. So here we have we've got, this is the original problem because the data set contains only the original problem, and we've got the type of response, correct, intuitive, other, and these are the counts, these are the proportions, and this is the estimation of the proportions on the population. So we do the same with the three data sets. So you go to file, and then we've got here here I've got them because I used them recently, but otherwise you go to computer and you find it in your computer. And okay, so we do the same for the blur test. We do frequencies, binomial test, put type of response here and confidence interval, and we've got here the confidence interval that we are interested in. We do the same for the mathematical, and these are the results. So we've got for the original estimation for the correct response is the proportion is 0.5, and the confidence interval 0.378 to 0.622, and we've got the same. We've got an estimation of proportion of each possible value of the dependent variable for each type of problem. Okay, so that's the traditional parameter estimation approach. For the Bayesian parameter estimation approach, we can use JASP as well, and as in the traditional approach, we are going to use the data sets that contain only one type of problem at a time, and we are going to use the Bayesian binomial test, but we are not interested in the test itself, we are interested in the prior and posterior. So let's go and do it. Here is JASP, and we've got the original, you can see here, we've got the original data. So instead of using the traditional binomial test, we've got the Bayesian binomial test. Again, this doesn't matter, we put type of response over there, but what we are interested in is in prior and posterior. And here we've got the median of the prior, the posterior, the median, and the 95% confidence interval of the posterior distribution. So here it just shows us the prior, and the prior is, as indicated here, is a beta prior with parameter A equals 1 and parameter B equals 1. That means that is equivalent to a uniform distribution, uniform continuous distribution. So the probability is 1 for any value within 0 and 1. So that's the prior, and this is the posterior distribution, which is much narrow, and it with mean of close to 0.5. Okay, so that's for the correct answer, and we've got one graph for each type of answer. So for the intuitive answer, the median is 0.430, and confidence 95% confidence interval of the posterior distribution 0.319 to 0.546. And for other, you can see it's much closer to 0. The median is 0.079 with a confidence interval of 0.032 to 0.157. So we do the same with the other data sets, with the blurred and the mathematical data sets, and we get these results. So these are the estimations of the proportions for each type of response in each type of problem. Okay, for the resampling approach, I did the analysis with R, so I'm not going to show you the analysis, but basically it involves resampling from the data we have rather than assuming some sort of distribution. So basically, just show you if we are in the original, we look at the data. So from these, we for the original type of problem, which is all because it's just the original, we've got a number of intuitive values, a number of correct values, and a number of other values. So what we are going to do is to generate a sample of the same number of participants or same number of values of 70 by randomly obtaining one of those values from this sample, and we record that value, we return it to the sample, and we again by chance randomly we choose another of those values, we record it, and we do that 70 times until we get a new sample of 70, and we calculate the proportion of correct, the proportion of other, and the proportion of intuitive in this new sample, and we record those three values, and we repeat the process thousands and thousands of times, maybe 10,000 times, in order to create three new distributions with proportions for correct, proportions for other, and proportions for intuitive. And the result for that is this. The correct answers are around 0.5. The intuitive answers here are a bit less than 0.5, and the other answers are closer to 0. So here are the again the parameters the summaries of the sampling distribution obtained by resampling for each problem, and within each problem for each type of response. Okay, so that is the end of video 1 that showed presented the case study and showed how to get the descriptive statistics with JASP and Jamovi, and we went through the 3 parameter estimation approaches.